In this video, we're looking at inverse proportion. That means as one variable increases, the other decreases. This isn't a linear relationship as we saw with direct proportion. Instead, we have a curve on a graph. And we can see as x increases in value, y is decreasing in value. A common example we can use to describe inverse proportion would be to think of the number of workers needed to complete a job. If we had 4 workers that took 6 hours to complete a job, it would take 2 workers 12 hours. Where we've halved the number of workers, that would mean it would take double the amount of time. On the other hand, if we had 4 workers who took 6 hours and we doubled the amount of workers to 8 workers, that would mean it would take them half the amount of time. So it would take 8 workers 3 hours. Looking at the symbol for proportionality, we still use this symbol here to describe the proportionality of something. However, when we are looking at inversely proportional to, we use the symbol but also introduce this fraction here. If we go over to our steps, we still have 4 steps that we use to form an equation that will enable us to solve other values for the variables when one is known. We start off our equation by doing the same thing as we did before, where we look at inversely proportional to being represented by our proportion symbol with 1 over. In our question it says G is inversely proportional to. Here we have G is inversely proportional to. This is what you are replacing the inversely proportional sentence to. It is inversely proportional to W, where W is under your fraction. We can now replace the proportional symbol and the 1 to become equals K. K is this constant. That remains the same throughout all of the equations relating to this relationship between G and W. We then look to go to step 3, where we use the given information to find the constant of proportionality. Now, in the question it tells me that G is 4, so 4 is replaced there. It says W is 9, so W is replaced with 9 there. We should know that this means divided by 9, and if we had a one-step equation that looks like this, we would multiply both sides by 9 to give me 4 times 9 is 36, is equal to this constant. Remember, this constant remains throughout. We substitute this back into our original equation here to give us G is the same. The proportional value for K is 36, so we've now found that 36, and W remains the same. We can use this to solve anything that is determined by the relationship we've stated above, where G is inversely proportional to W. If we look at the my turn example, it tells me that Y is inversely proportional to X. That means I'm taking my Y and I'm saying it is inversely proportional to, and using the X underneath. Now I'm going to write those in. So we have Y is inversely proportional to X. That is our step 1. Our second step is to show this using a K value instead of the symbol. We are keeping the Y, introducing an equals K, the fraction is still there, and now X is underneath. We know that Y is equal to 4 in this instant, and X is equal to 6 in this instance. And we will substitute that in so we can work out the value of k. So y is 4, and that is equal to k over x, which is 6. We should know that this means divided by 6. So to calculate what k is, we would need to multiply each side by 6. That gives us an equation, or a value of k, as 4 times 6 is 24 is equal to k. We want to substitute this value of k back in to this value here. For our step 4, that means y remains as it is. It is now equal to 24 and over x. This is the entirety of the equation for y and x has been solved here. We can now use this to work out what y is when x is 2. So part B would be to substitute the value of x is 2 into this equation here. So we have y is equal to 24 divided by 2, giving me y is equal to 12. Press pause while you try the your turn example. Okay, so in this example, we have y is inversely proportional to x. So this inversely proportional can be represented as the proportional sign with 1 over a fraction. We want to ensure that we are using our y value, which is before the inversely proportional to, and our x value, which would be under our fraction. So that means y and x go there, and we have shown that y is inversely proportional to, okay, so that's what that bit means, x. Our step 2 is to represent this inversely proportional to as an equals k as our numerator of the fraction. So we have y is equal to k over x, where k represents this part here. Step 3 is to substitute our values in for y. Now we can see that y is equal to 8 and x is equal to 6. That means we have got 8 is equal to k over 6. A one-step equation we have here, we will want to get k on its own, and at the moment it's being divided by 6. That means we would multiply both sides by 6 to work out what k is. 8 times 6 is 48, which is equal to k. We would like to substitute this in to our equation that we had here to help us form the equation for y and x. That means for step 4, y is still as it is, the equal sign is still as it is, k we now know is always 48, and we are dividing that by x. We can now use this to calculate any value of x or y when the other one is known. In the next case for B, we are asked to calculate y when x is 8. So we know this value is 8. So we rewrite y is equal to 48 divided by 8, which means y would be equal to 6.